Determine the area of each figure. We're going to break this up into shapes that we know. And find the area of both pieces, then combine them to find the total area. Here I can break this up into pieces as well. This rectangle would be 2/3 by 4/3. 2 times 4 is 8. 3 times 3 is 9. Excuse me. This one is the same. So that one is also 8/9. This piece here is 1/3 wide, and this was 4/3 tall, and this piece was 1 tall, or 3/3. So that leaves us with 1/3 by 1/3. 1 times 1 is 1. 3 times 3 is 9. So I have 8/9 plus 1/9 plus 8/9. Well, 8 plus 1 is 9. 9 plus 8 is 17/9 inches squared. So Tara and Blake are each filling a swimming pool. Tara is filling an L-shaped pool, and Blake is filling a rectangular pool. Blake says that the rectangular pool will hold less water than the L-shaped pool. And Tara says that the rectangular pool actually has a greater volume than the L-shaped pool. When they wonder about which pool holds more, are they discussing surface area or volume? They are talking about volumes of the pools because when we're thinking about the amount of water that fills a pool, going inside of a 3D object is volume. They are trying to determine which pool holds more water. Before we begin solving to find out who is correct, I want you to make a prediction about which pool you think would hold more water, or in other words, which pool has a greater volume. Now we'll need to think about how we can decompose the L-shaped pool into two solids that we can find the volume of. We could decompose our shape by cutting it here, or we could cut it in this direction. If we did that this way, this piece here is 6. So this piece here has to be 6. But then to get 11, this section here must be 5, because 5 plus 6 makes a total of 11. Let's find the volume of this piece here. The base area is a 5 by 10, so it has a base area of 50 and a height of 4.5, which can be rewritten as 4.5. So the volume of that section is going to be the base area of 50 times the height of 4.5, which is 225. Then we still need to find this section here. It is 6 wide, and it is 5.5 feet across. Which is 33 for the base area. It also has a height of 4.5. So to find the volume of that piece, we're going to multiply the base area by the height, which is 148.5. So altogether, Tara's pool, we need to add these two values together for a total volume of 373.5 feet cubed. For Blake's pool, the base is 10 by 8, which is a base area of 80, and it has a height of 4.5. $80 times 4.5 is a volume of 360. So the L-shaped pool holds more because 373.5 is greater than 360. For problems 1 through 3, all angles in the diagrams are right angles. Which pool has a greater volume? Show how you know. Well, Julie's pool is an L-shaped pool, but it has a deep end. And Blake's rectangular pool is the same as before. So we know that Blake's holds 360 feet cubed, but we need to calculate the volume for Julie's L-shaped pool. If we cut the pool here, you can see we have a 5 by 4.5 base. So 5 times 4.5 tells us the base area. And the height of this whole section is 6, which is a volume for that piece of 135. Then we have this section here, which is 11 by 5.5. And 11 times 5.5 is 60.5. And it has a depth or a height of 3 feet, which gives us a volume of 181.5. So the total volume for Julie's pool should be 316.5 feet cubed, which means that Blake's pool holds more. And it has a greater volume than Julie's pool. Determine the volume of the solid. Show how you know. Well, we can cut it into two sections just like we have been doing. This piece here has a base of 13.5 by 1.5 and a height of 6, which is a volume of 121.5. And then for this piece, 13.5 minus 10 leaves us with 3.5 wide. It is still 1.5 across here. It matches that same piece. This whole height was 12, but we've already used 6 for the bottom piece. So we have 6 left for the top piece because 6 plus 6 makes 12, and 3.5 plus 10 makes 13.5. So the base area would be 3.5 by 1.5, and the height is 6. Which is a volume of 31.5. So the total volume is 121.5 plus the 31.5, which is 153 centimeters cubed. Which expression represents the volume of the solid in cubic meters? If we cut it off here, this would have a base of a 4 by 2 and a height of 1.6. Here I see a 4 by 2 with a 1.6, a 4 by 2 with a 1.6, and a 4 by 2 with a 1.6. This one also has that represented here. Now let's look at the other section. This would be 1.6 by 2. If this whole height was 8 and we already used 1.6, the piece that would be left for the height of this section here is 8 minus 1.6, which is 6.4. So we need 2, 1.6, and 6.4. 2, 1.6, 6.4. This one does not have that. Neither does this one or this one, which means it must be D. Here it shows those separated out so you can see that the 1.6 and the 6.4 make up that full side length of 8. Here I have 3 solids. The solids we've examined so far were L-shaped and could be decomposed into 2 right rectangular prisms. Sometimes you need to decompose a solid into more than 2 prisms. Or you could use other strategies to determine the volume of a composite solid. So for example, maybe you're going to cut this into 3 parts, or this one into 3 parts. This one you might need to find the outside and the inside and use a different strategy. What is the volume of the solid? Show your work. So we're going to cut this one, like we mentioned, into 3 different sections. So this first section has a base that is 1 by a half, which can be rewritten as 0.5, and it is 2 tall. This next section, we have this piece that is 1 and this piece that is a half to make a side length of 1.5. This was 2 wide, but we used 1, so now this section here is 1 wide, and it is also 2 tall. This was 4, but we already used 1 here, so this distance is 3 by a half. And it is also 2 tall. To find the volume, we need to add those three sections together. Well, this blue section has a volume of 1. This red section has a volume of 3. And this green section also has a volume of 3. For a total volume of 7 meters cubed. A donut shop makes square donuts as shown. What is the volume of the donut? Show your work. For this one, we're going to find the volume of the outside and subtract the piece that's been removed from the inside. The base area here, it's a square, so that is a 3 by 3, and it is 1.5 tall. The piece that has been removed from the inside is a 1 by 1 square that is also 1.5 tall. But for these, since it's removed, we need to subtract. This blue section here, or the outer section, is 3 times 3, which is 9, times 1.5, which is a volume of 13.5. The red section is 1 times 1, which is 1, times 1.5, which is 1.5. Then we will subtract them to find the final volume. 13.5 minus 1.5 is 12 inches cubed. Mr. Sharma makes steps out of concrete as shown. The height of each step is 7 inches. On the 2 bottom steps, the top of each step measures 10 inches from the front edge to the back edge. How many cubic inches of concrete does Mr. Sharma need to make the steps? So we can cut these into layers, or we can cut them into chunks vertically. Let's use the layers here. Let's start with that orange layer. The orange layer has a base area that is 40 by 40 and a height of 7. The blue is 40 across the back, but this time instead of 40, it's now 40 plus an extra 10, so 50. 40 along the back, 50 along the side, and it is 7 tall. And this green section, it was 40 to here, 50 to here, and then an extra 10, so now it's 60 wide and 40 across. But it is also 7 tall. So for this orange layer, 40 times 40 for the back is 1,600, times 7 is 11,200. Then 40 times 50 for the base area of the blue is 2,000. And if we times that by 7, that gives us 14,000. For the green, 40 times 60 is 2,400. Multiply that by 7 for the height, and we get 16,800. So if we're going to find the total volume, we need to add these three things together. For a total volume of 42,000 inches cubed. That is the end of lesson 18 for module 5. Check back here for additional videos.